Ladies and gentlemen, hello and welcome to the webinar. Today's discussion is focused around quality and its direct impact on the bankability of the solar assets. With the topic of the webinar, optimizing LCOE, the impact of reliable materials and components. My name is Gosia Surowiec. I'm a project manager at Solarplaza, and I'm here today with Peter Karam from Vector Cuatro and Olivier Haldi from Stäubli. So what is our agenda for today? I will start with a short introduction and some background information. Shortly after, we will move to presentations from our panelists, Peter and Olivier. Peter and Olivier will discuss what and how can be done at the very early stage of development to ensure longevity and reliability of the solar PV project. They will also go into details on the importance of reliable materials and components and the role they are playing in overall bankability of the solar PV plant. Since I would like you to get involved in this discussion as well, afterwards, we will leave some time for Q&A. We will end the webinar in about 1 hour. So for those of you that don't know Solarplaza that well, we are a global information platform for solar PV. Our main business is organizing high-level B2B conferences and trade missions, over 100 in last 13 years, in more than 30 countries. Currently, we have a network of over 60,000 solar professionals, and we are growing every year. This webinar is also a prequel to our 6th edition of Solar Asset Management Europe conference, which is devoted to optimization of the operational phase of solar PV assets and portfolios. This year, we are expecting over 350 participants with more than 60 experts on stage, which are going to share their experiences and best practices. We have more than 40 sponsors and partners that make our content and conferences possible, including the speakers of today, Stäubli and Vector Cuatro. The conference will take place already in 2 weeks, on 23rd, 24th October in Milan in sunny Italy. If you would like to register, it is still possible on our website, solarassetmanagementeu.com. Some practical notes before we start. If you experience any technical issues during the webinar, please use chat box. For any questions you might have to our panelists, please use question box. You can send your questions during the presentations, and we will address as many as possible during the time allocated to Q&A. And of course, the presentation slides will be available afterwards. Our first speaker of today is Peter Karam, the Head of Technical Asset Management at Vector Cuatro. Peter has several years of experience in the design and technical analysis of solar PV projects in Europe and overseas. Currently, together with his team, he is supervising over 500 megawatts of renewable energy assets. Our second presenter is Olivier Haldi, the Global Business Development Manager at Stäubli Electrical Connectors. Olivier has been with Stäubli for over 2 years. He is currently responsible for global key account management, leading internal projects and supporting subsidiaries. Okay, let's begin the presentations. Peter, you have the floor starting now. I'm giving you control. Please go ahead.
Thank you. Thanks a lot, Gosia. Hello, everyone, and thank you for attending wherever you may be and whenever you may be. I know this is going to be registered and put on the website a bit later. Just lagging here a bit with the mouse. Yeah, so before jumping into today's presentation, I'm going to do a quick intro of Vector Cuatro, where I've been working for nearly 6 years. The numbers in brief, as you can see, we have 2.4 gigawatts under asset management, 53 gigawatts of carried out technical services in more than 22 countries, and last but not least, 4.6 gigawatt of transaction services rendered. Some fun facts about us. We are present in 11 countries on 9 different time zones, and we have 12 languages spoken in-house as of this recording, which is quite fun, actually. There is no language that we need. Yeah, if we can please now put on the first poll question.
Yes, I'm going to do it right now. Okay, now our audience can see the question. I will read it for you. So what is the cost center that most affects the LCOE? CapEx, OpEx, both, or others? And now we'll give few seconds for our audience to answer.
Please don't hesitate, guys. If you're selecting others, just leave a comment in the question box that we can review later.
Okay, one more second, and we're going to close. Okay, let's show the results. So Peter, looks like we have no clear answer. Looks like majority of our audience say 41% of both, with OpEx leading that. What do you have to say about it? How do you feel?
Let's see how it goes. Let's take it step by step then. Yeah, the poll question was to have everyone participate as much as possible. I know I'm the only one talking, but I hope that everyone has a voice here. So Gosia, I'm sorry, I didn't have time to note the answers, but I'm gonna come back to that later. Okay. Let's take a look now at simple definition here, mathematical definition of what's the levelized cost of electricity. For those who are not familiar with it, luckily it's quite easy to understand. It's the sum of the costs over the lifetime of the project divided by the sum of the energy produced over the same time period. LCOE can be used as an index in any electricity producing industry, but obviously we're here to discuss solar PV specifically. I'm going to dive into the perspectives at hand. When it comes to solar PV projects, these are the 3 main, let's say, category owners that I identified. When it comes to approving a loan, lenders tend to focus on the reputation of the sponsor, the bankability of all the chain related to the investment being done, such as the contractors, the providers, and mostly the equipment manufacturers. When it comes to taking a loan, I'm talking to the ones that do take loans, not to the ones that go full equity. Sponsors consider closely cost-benefit analysis of the projects. The idea here is that no one wants to invest in a project that's planning on losing money. And finally, the asset managers, which is the family group to which I belong, look at the potential production downtimes that the project can suffer. Please note that downtime here is the key word that allows us to think in terms of currency per kilowatt hour produced instead of currency per watt peak installed. In other words, the asset manager keeps a close eye on the downtimes, and that's a major part of what is done here. Because the longer the interruptions in production, the higher will be the LCOE. So in order to optimize it, we need to have the lowest downtime possible. Now, before passing to the case study I have prepared for you, I'd like to point out that contrary to popular belief, having the most expensive equipment may not be the best strategy. Price is not the only factor to take into account when going through the procurement phase in your project. You must also look at the responsiveness of the after-sales service and the efficiency with which resources such as spare parts and technicians are allocated to better reduce the downtimes that you're having. Basically, this is to say that a cheap brand that's been approved by your asset manager based on the experience that they have with them, can be more profitable than an expensive brand that has a bad after-sales reputation. Your project may suffer less downtime with an expensive brand, but the risk is that they are substantially longer, which results in a worse LCOE in the end. Okay, so we're passing now to the case study that I have prepared. I took the liberty of selecting 2 PV projects from our portfolio, which are identified here as number 1 and number 2. For the sake of simplicity, I'm only going to review the costs related to the inverter transformer station, which is ITS to the right in dark blue, in the different phases of the project's lifetime. So what we can clearly see here is that project number 1 gambled in selecting a cheaper ITS, which represents 7% of the total EPC price. While project number 2 selected a solution that cost him 9% of his EPC price, which is more or less 30% more expensive. The following concept that we see is that on the O&M contract, the average cost for preventive maintenance of the ITS is 18% over the lifetime of a project. And it's the same, on average, it's the same for any type of ITS, considering that they're similar in characteristics. So far, what we see is that project number 1 would have a cheaper LCOE since the costs are still a bit lower on his side. The third concept is contingency. What I represented in contingency are all the corrective maintenance costs and warranty extensions that could have been imposed by the lenders due to, I don't know, lack of trust or lack of bankability of the companies. Here we see a clear difference in the sense that by selecting cheaper ITS, the sponsor can incur, and in this case has incurred, in a lot of unplanned expenses. But as I said earlier, this is not the only possible reason. I mean, if it's been selected a cheap solution that the asset manager has approved, we may end up having contingency number 2 in the model number 1. But in this particular case, it's not what happened. So finally, we see in the total pie charts that project number 1, although starting with a cheaper solution, ended up having more expenses related to the ITS, which is to say a higher LCOE cost. And of course, this is not the aim. Okay, so as an opener to my presentation, apart from having discussed the correct, let's say, selection of the equipment, I plotted 2 breakdowns here of 2 EPC contracts of the same geographical area, but that were built 5 years apart. The concepts that I'm highlighting are the ones that had significant changes over this lapse of time and are of comparable brands and characteristics. So the modules, the ITS, and the structures. For your reference, some fun fact here is that the project built in 2016 has close to 3 times more peak power than the one built in 2011 for the same price. So we can see here that also the evolution of manufacturing processes and market needs have an impact on LCOE. This part I consider being a passive consequence, let's say, compared to the active selection of the equipment that we saw in the earlier slide. So I'm going to conclude here my presentation with, again, the same poll question, just to see if someone had a change of heart. And of course, for those logging others, just don't hesitate to drop a comment in the question box.
Okay, so we have the same poll question once again. So what do we think now? What is the cost center that most affects the LCOE? Are there any changes? Is it CapEx, OpEx, both, or others? I will give it a few seconds to answer. Okay, let's close the poll question now, and let's see the results. Looks like we have very similar answers. There is still 42% for both and 38% for OpEx, so it does increase 1%.
Yeah, I'm happy to see that some people changed their mind from capex to both and OpEx, and I would really be curious to know what the people voting for others thought about that. And that's all from my part, Gosia. I'm gonna hand over to Olivier that has some very interesting slides prepared for us.
Thank you, Peter. We will come back to you with a Q&A at the end of the webinar, so please stay online. I would like to remind you before we continue that the questions are open, so feel free to make questions at any time, and we will address them afterwards. Now we will move to presentation from Olivier. Olivier, the floor is yours.
Okay, thank you very much, Gosia. First of all, thank you very much also to the audience for joining us today. And of course, also thank you to the co-panelist Peter for making this webinar possible today. We as a manufacturer of PV cabling components know pretty well that at the first sight, talking about connectors might look like not the most attractive topic, especially in times when the industry headlines are dominated with topics more like digitalization, blockchain, and smart energy. But don't get me wrong, without a doubt, all the different efforts, strategies, development of the industry with the aim to increase the competitiveness of solar, the efficiency, profitability, reliability are very important. But we still have to take care about the basics, the groundwork as well. And sometimes it's really like you cannot manage the unknown. So as you will see in the next couple minutes, not talking about basics like the cabling components in a PV system can be very, very costly. So that's also why we are quite convinced that this is a relevant topic for the industry and especially also for asset owners. Of course, before we jump into the topic, just a few words about our company as well. Stäubli is a technology leader and pioneer in the fields of electrical and fluid connectors, robotics, and textile machinery. Today, we can build on more than 125 years of experience and 5,000 employees in 29 subsidiaries all over the world. The division Stäubli Electrical Connectors, which was formerly known as Multi-Contact, has been part of the Swiss family-owned Stäubli Group since 16 years. And beginning 2017, Multi-Contact also then took over the Stäubli brand. So track record in the industry, we have been a pioneer in the field of photovoltaics, and the first industrial photovoltaic connector, so-called MC3, was introduced by us already in 1996, followed by the original MC4 connector in 2002, setting kind of industry standard. And today, more than 210 gigawatt photovoltaic capacity has been installed with our photovoltaic connectors, which is amounting almost 50% of the global cumulative PV capacity. So yeah, as you know, with the current cost pressure climate, yeah, developers or IPPs quoting aggressively low prices, squeezing profitability, and the need for cost reduction strategies in the solar industry is of course growing. But we have to be, or we have to question ourselves, isn't there maybe kind of a mismatch between what solar owners and investors want, and on the other side, what also diligent EPCs can realistically deliver, and how to maintain the quality, profitability, reliability in the in this kind of financial squeeze. So generally, core pillar of cost reduction is, I would say, taking care about details, and at the same time is to set the foundation right at the very early stages. Yeah, in order to avert any avoidable extra costs in future and ensure reliability of the project with yeah, the overall lower levelized cost of energy, and what also Peter mentioned already, not only concentrating on the initial cost of a PV project. Yeah, but what is now the correlation with the EBOS components? EBOS means electrical balance of system, and in particular with connectors. Yeah, what is our experience on this, and what do we see respectively also here from the market? Yeah, first of all, it's really that we face a huge lack of knowledge about the topic PV cabling and connectors. Yeah, about the products, but as well about the correct handling, the installation of these products. The technology, what are the norms, materials, production processes, and also relating to the installation, the handling, what are the correct tools you have to use, the assembly instructions, and as well the norms we have there. And secondly, as well, yeah, what is the relevance of these components for the financial success of a PV asset? I mentioned already, you can't manage the unknown, and that's why I think it's so important that we talk about this small components as well. Yeah, and what we hear quite often also are comments like connector, what's that? And nothing happened so far with our products. No problems with connectors. Is connector A compatible with connector B? Your products are too expensive, or I have a certificate and a data sheet for the product, so that's enough and guarantees the quality and the reliability of the product. Yeah, but at the same time, we feel that today also project owners pay more and more attention to the quality of components. Mostly though, yeah, they focus on modules and inverters, which represent the largest portion of the capex. But with the rest of the components, mostly they say that's up to the EPC. Of course, depending on the business model of the EPCs, but yeah, mostly they go then for the cheapest solution as well. And because of this lack of knowledge, especially among the investors and project owners, they kind of underestimate or do not focus on these components, and then they don't see and don't know the relevance of these. Yeah, connector might be a small part, both physically and in terms of weight of the total system cost. But if you consider that, yeah, you are investigating or investing a lot of money, and you pay a lot of attention to selecting the right models, the right system design, then you also want to the energy that you are producing is transmitted efficiently, and the part which is the energy is flowing through is then at the end, of course, the connector. So as you will see in the upcoming slides, results of third-party studies as well as our own experience shows that there are huge numbers of issues with cabling connectors, and they have a major influence on the efficiency, the return on investment, and at the end of the day, as well, of course, on the levelized cost of energy of the PV system. So the aim of the presentation is to increase this awareness, why it makes sense to pay attention also to these basics, like the EBOS components. And here what you can see on this slide, the recent data from third-party GTM research with some numbers on failure patterns in existing solar assets in 2016 compared with 2017. And as you can see, almost stable, around about 1/3 of detected failures in PV systems are related to the cabling system. So this is just the first indication that the industry have seen a lot of issues related to cabling connectors, and at the same time that the potential for improvement is quite huge. On this slide here, I want to share some data with a kind of more practical focus. We have been called recently for help in a huge ground-mounted PV system in Latam, only 6 months after the construction of the site. Even we haven't been involved in this project, and none of our products have been used. So they called us because of several broken, respectively burned connectors in the system per week, and some low voltage at the inverter due also to this connector issues. At the same time, the detection of these failures, burned connectors, is very difficult because in this system there is no string level monitoring, only block level from central inverter communication system. So yeah, this is kind of also an example where we have to say project managers maybe did some wrong decisions in the early stages of the project. And here you can see also what we've reported after the site inspection. We've been investigating the connectors and cabling management in the system, and found some first indications for causing these failures. Connectors, we detected no cross connection in the system, only on the tracker controllers. Sometimes connector nuts are not properly fastened. Some can be easily unscrewed by hand. We detected some in some connections having a so-called female to female or male-to-male contact part inside the plastic housing, mechanical stress on the connectors, and so on. Cabling side, conduits not UV rated, showing already cracks. To keep it short, we found several issues related to bad or incorrect installation management, but as well the quality of the components must be critically questioned here. So what are the consequences? Of course, performance loss. We do mainly downtimes of modules or entire strings. We have extra service repair costs. Developer is also issuing the connector insurance claim to module manufacturer, as the connectors have been provided by the module manufacturer, and the warranty claim to EPC for improper installation. And as well, the handover to the O&M company is postponed because of this current issues in the system. So the solution they have at the moment is currently they are just replacing the failed connectors one by one. But to be honest, yeah, we expect that the whole cabling system has to be replaced, as it will be in the long term the more cost effective solution, we think. Financial impact. Currently, it's not really possible to give an exact statement here, as they only know that performance is not close to expectation, but because as well the iridium sensor is not working, and they have no clear picture about the downtimes, I mean the time to detection, time to repair of the failed connectors. Yeah, at this time it's hard to give a number here on the financial impact. So here, finally, another third-party result you might be already aware. As you know, typically risk and failures have been analyzed in a failure mode and effect analysis, but this won't give you an indication on the financial impact. But yeah, to be honest, I think this is what it's all about. And the solar bankability project, funded by the European Commission's Horizon 2020 program, aims to establish a common practice for this professional risk assessment on the basis of existing studies and collected statistical data of failures in PV plants. The risk analysis then assess the economic impact and the technical risk, and how this can influence various business models and the levelized cost of energy. So the project then presented cost-based failure modes and effect analysis with a so-called CPN, cost priority number. This was then invented for the calculation of the economic impact, and it corresponds to the risk priority number of the classic failure modes and effects analysis. And this then has approached and applied to the collected failure data in order also to prioritize the risk and the economic impact of this CPN ranking. I also have to keep it short here. It's not possible to explain the whole methodology in this short time, but you can get also the results. They are public on solarbankability.org. But main message is also clear here. It's absolutely worth to pay attention to the risks and failures related with connectors and cabling. And as you can see here on the slide at this figure, top 20 technical failures, shows that wrong absent cable connections or broken burned connectors can have a big financial impact and are here at the top of the list. Yeah, the results and the data presented demonstrate that cabling connectors can have a huge impact. And the rising question is now, what is then the root cause of these issues? What is the correlation, and why small components like connectors can have such an impact on the overall yield? And what is a feasible way also to reduce this associated risks? The cabling of a PV system has to ensure the stable transmission and the generated power from the models by connecting them to strings, combiner boxes, inverters, or the consumption then. And to guarantee a fast and safe, flexible connection, the first connector system has then been invented by us in 1996 for the PV industry. To put it here simple, for a connection, you need a plug, so-called male, and a socket, a female cable coupler. And each of them consists of a contact, a metal part, and an insulting, a plastic part to protect the connection. So therefore, yeah, connectors are used in large numbers. For instance, in a 100 megawatt solar park, you have around 700,000 connectors installed. And the key to efficient operation and energy feed-in is a constantly low contact resistance. And yeah, vice versa, an increase in contact resistance inside the connectors will induce higher temperatures and power loss, which will have a negative impact on the contact resistance again, thus then creating kind of a spiral resulting in a high risk of connector failures. So the consequences caused by these failures lead to power loss due to downtimes, as shown in also this practical example from the system in Latam, expenditure on service hours, cost for spare parts, and in a worst case scenario also yeah, can lead to hotspots or even a fire. Yeah, this will all lower the revenue and the energy yield. So the financial impact, of course, is depending on a lot of different factors, how often and how many connectors are affected, where in the system, is it only on model or in entire string, or even the whole PV plant is disconnected, as well, of course, the reaction time for, or what monitoring system the owner is running. So the key actually for operational efficiency in this context is this yeah, low contact resistance over years. But what can cause or what can be the roots for an increase in contact resistance? What are the main sources of risks? First, quite obvious, yeah, the quality of connector. So of this component, so selecting a quality connector is there a way to avoid this and as already touched, the reliable performance over years and the quality of the product is key. Means the selection of all the different upstream components with real quality. So most of the time, it's really you get what you pay for. Yeah, but as you have seen, the smallest component can be systematically relevant, and if yeah, it's the weakest, at the same time, the system can be put on risk here. So this illustration here at the top left corner, for instance, shows the result of a standard norm testing. So every connector has different contact technology, dimensions, product material, product processes. Yeah, and the quality connector here is the green curve is almost stable in terms of temperature and contact resistance after this testing, this stress testing. So the use of low quality connectors, however, is very risky and yeah, can strongly increase the contact resistance. It is almost impossible on the other side to foresee by when an increase in contact resistance will lead to a connector failure. Could be at day 1, after 3, after 4, or after 6 years, but sooner or later it can lead to the mentioned consequences. So yeah, the quality of a product cannot be recognized or even proven only by a manufacturer's data sheet or a specific yeah, certificate. Then also the selecting of reliable product is only step 1. But yeah, as already mentioned, the correct handling, installation, respectively also selecting the right partner with well-experienced, trained technical staff, and as well, I would say a clear commitment to a quality approach are crucial for the system's profitability. Yeah, in this relation also, yeah, the cross connection topic is one of the main topics as well. Yeah, there are as well we have different norms as well in the industry. So there is no compatibility, no certification for cross connection. There is a product norm for connectors, the IEC 62852, for instance. If a plug connector from a manufacturer A and is connected with a socket connector from manufacturer B, the certification is not valid anymore. Also the UL, there is a UL norm on modules requiring module manufacturers to list on their model and assembly instructions the specific manufacturer of the PV connector, yeah, this helps installers also then and inspectors, as they have a very clear instruction on what connectors can be used. And there is also an installation norm. It specifies that plugs and connectors, socket connectors made together in PV system shall be of the same type and from the same manufacturer to make the connection. Yeah, also in terms of correct installation, we see a lot of issues caused by the so-called crimping, means the connection of the plug and the socket connector, or more precisely the contact parts to the cable. Yeah, a well-engineered and well-executed crimp is designed to be gas-tight, which prevents oxygen and moisture from reaching the metals and causing corrosion. Yeah, these are just a few tips on this, and of course the involved project stakeholders might have a slightly different view regarding their intentions. So in order to lower the capex, one may try to lower also the asset costs of cabling and choose low quality products or cheap workmanship. In this context, and with having a focus on components, on not on handling, and it is interesting also to note that components for cabling comprise only around 1%, for connectors only 0.003 of their overall total initial cost. So yeah, also then price savings among these components are very, very low. So yeah, I think therefore it is really appropriate to ask if these small savings in total initial cost gained by using maybe cheaper components is justified when considering the additional safety risks during operation period and decreasing efficiency or return on investment in the long term. Yeah, such a choice then might bring. The findings of the solar bankability project gives an indication on the economic risk in an average of this risk and failures. But for any single project, of course, they are depending on a lot of different factors and can't be really calculated also in details. So going to the next slide here. So the complexity actually of PV project, we can say details really matters to mitigate the risk and to ensure the return on investment of PV system. This can I think only be achieved through secured efficiency in the long term on the basis of high quality components and workmanship. So therefore, you have to make the right decisions at the early stages. So wrong choices in planning to most of the time lack of knowledge or low quality components can cause unexpected loss of production and potential safety issues during the life cycle of a PV system. So on this slide here, yeah, what are the core topics we see mainly here in the conception phase of a PV project? Yeah, as really important. First of all, of course, yeah, you have to focus on the system design, respectively on the electrical design. Means, yeah, what is the monitoring system? What are the exact specifications in terms of the design? Also, what is in the details in the contracts with your contractors, maybe also subcontractors, specifications on that, of course, following the installation norms, or as well the assembly instructions of the manufacturers, always with the focus on balancing the levelized cost of energy. Then as well, components, of course, yeah, the product quality. As you know, the smallest component can be systematically relevant, and if it's the weakest part in the system, yeah, the whole system can be put on risk. So the quality of the product cannot be recognized, as already mentioned, by only the data sheet of the manufacturer and the specific certification. That's not enough. So generally, we recommend that, yeah, you should try to assess these components and the manufacturer behind in the same way you do for models and inverters. Yeah, production processes. One of the challenges is really maintain a constant high quality level. What is the track record of the manufacturer? Warranties, do they have beyond the norm testings? Who are the partners, references on the model side, on the inverter side, EPCs? Yeah, also the bankability of the manufacturer, the expertise, service, and yeah, as mentioned, I think audits, factory audits, visual inspections of production sites can be also a way to assess this kind of products. Partners, yeah, I would say the similar values and deliverables as we have on the component side. Do they have the quality approach? Do they have the well-trained staff, experience, track record, as well, bankability? Yeah, work together with players who are really committed to the quality approach and are well experienced with well-trained staff. Then in the next stage of the PV project, the construction there, we would say mainly is, yeah, following what has been defined during conception period, respecting installation norms in the industry, the assembly instructions of the manufacturer, and as well, yeah, supervision of the whole, yeah, coordination, the cable management, a proper installation, and the different installation steps. And then at the end, in the operation period of the system here, if you have done a good job already in early project stages, yeah, in this phase, it's all about monitoring, inspection, visual inspection, thermal cameras, checking the cable management, and I would say also a local support and expertise is, yeah, one thing you should take care. And yeah, so that's it from my side.
Okay, thank you. Thank you very much, Olivier, for this very detailed presentation, very informative. Since now we still have a couple of minutes, so we will move to the Q&A. Of course, you can continue to send us some questions while we are answering the one that we have already. So let's start with the first one. And this one is to you, Olivier. In terms of the failure patterns, how do you see these patterns changing in the future? And if the pattern is geo-specific? So I think the two questions in one for you, Olivier. you like to take it?
Yeah. Yeah, in the future, of course, I would say I can mainly approach here the failure patterns on our components, on the cabling and connectors mainly. And of course, our goal is with quality components, but as well with the education of the industry and the players in the industry, mainly also on EPC side, yeah, is of course to bring down this failures we still see in the field. And it's not only that we see this kind of issues already in more mature markets like in Europe or in the US. We see it already also in emerging markets like, of course, India and China as well. But I think one of the core topics we also will focus and concentrate is really try to create more awareness about how important it is to take care about the whole electrical cabling management of a PV system.
Okay, thank you, Olivier. And this is another question which is actually related. So installations are one of the common causes of failures. So how do you make sure that you choose the right installer? Is there one relevant certification in Europe specifically?
I mean, yeah, there is of course an installation norm, the IEC 62548. Yeah, it's as I mentioned already, selecting the right partner here is not so easy. I would say, yeah, you should also do kind of an assessment here, checking the track record. What I mentioned also, is it a partner who is committed to the quality approach? What is the track record there? Can they also give some examples of existing PV systems construction they did maybe 4, 5, 6 years ago already? Yeah, what we also experience a lot is that you have this kind of EPCs looking for more spot business, just do the construction and then, yeah, maybe 2, 3 years later, they're not there anymore because they also went bankrupt. So yeah, it's not an easy task, but I think there are some well-established EPCs, not only in Europe. Most of the time, they also are now, of course, active in emerging markets. And I think this is already a good indication. Related to the insulation topic or the cabling topic, I would also recommend to ask some questions about that related to the insulation norm, cross connection topic. Of course, do they really take this serious? Also, yeah, maybe what is the training about on the technical stuff? Do they have regular trainings as well? Yeah, this kind of activities we would recommend.
Gosia, Olivier, if I can be so blunt, just to add a quick detail. Actually, when you're entering a market and you don't know which EPC, which installer to go with, the best, in my opinion, is to go to someone who already has after construction experience. So you go to, in my case, an asset manager, but you can go to other asset owners and ask them about the experience that they had, because in our history here, we have seen that it's not only about following the norms or being accredited or so on. There is a lot of talk that's also very helpful when you're taking this kind of decisions.
Absolutely, Peter. I agree on this. It's not all about only norms, but of course, it's already an indication if you ask about this norm and the EPC or the installer is not aware of this, then this is already kind of indication maybe. Yeah, that's I would say that maybe it's not the right partner you should go, but it's of course definitely more about just following the norms. Absolutely.
Okay, so let's thank you for this, and let's move to another one. We have quite so many questions. So I think maybe you can answer this, Peter. We have a question. Are we moving away from the EPC model, considering the number of faulty installations now being seen in the first 2 to 3 years of operation? What do you think?
Yeah, moving away from the EPC model, but going towards which model in particular? I don't know if the person is still connected to complete that part. What I think is that, as Olivier mentioned as well, you have two types of market: the market of EPC contractors that are here to build and disappear, and then you have a market with a lot of contractors who are here to build and stay. We tend to see coming back again on the market a lot of long-term O&M contracts that are companies affiliated with the EPC. So we kind of have here two markets forming in the same countries sometimes.
Okay, Peter. Thank you. I don't have nobody specified, so I think let's move to the another one, because there's another question for you. And I wanted to ask you, so what are the energy gain they usually provide by Vector Cuatro and technical management services? What are the main functionalities they used in comparison to others? I think they want to. Yeah, so this is specifically for you.
Okay. I'm very sorry to say I cannot talk about others because I'm not here to talk about that. But I'm happy to have a chat with whoever asked that question. What we do, our main differentiator here is that we have quite an extensive range of projects and technologies, and we have projects that use Stäubli connectors. So if you have any feedback related to that, we're very happy to reply. And yeah, on the market, we are the only ones maybe on 9 different time zones. That's a fun fact, but it's still relevant. We have quite an extensive experience on everything that happens before construction, at equipment selection, and after construction, and we use our experiences retroactively to help clients in the design phases of their project. So yeah, we're here to accompany on the whole cycle of a project's lifetime.
Okay, thank you, Peter. So we're running out of time, and I think we have time only for one last question. I think this one is for both of you. So I think you both agreed that quality requires holistic approach. Are there any standard measures that show the correlation between the failures of different components? And is this included in your analysis, or do you focus on single components independently? Maybe Olivier, you would like to repeat?
I'm going to take over here. I think Olivier is still muted. From our perspective, we don't look at single components. We look at all the failures of any project at any given time, and then we filter by component to help us determine what caused, determine the cause of the failures. I don't know if I'm answering exactly to the question or I'm missing a part of it.
No, I think you're doing great.
I mean,
Olivier, would you like to add something to it?
From our perspective, of course, as a manufacturer of connectors and cabling components, we mainly focus on our components, and as well, of course, also failures and risk we see in PV systems related to these components. But you have to keep in mind that as well, connectors are equipped to modules and inverters as well. So these kind of components then also can have a direct impact, or can be a root cause for failures related to modules and inverters as well. So this, of course, we also take care and have in our focus. But definitely, I think it's absolutely the right way to have a holistic view on the whole system. But what I mentioned as well, and not only on certain components like the modules and inverters. That's the right way, but it's not enough.
Indeed. Thank you so much. Unfortunately, we don't have any more questions and any time for other questions. So with that, we will wrap up our webinar. And so thank you for all your insights, Olivier and Peter. Thank you to our participants for their contribution and active participation. If you have any further questions or remarks to me, here are my contact details. Feel free to contact me. And the recordings and slides will be, of course, available afterwards. And I hope to meet at least some of you in Milan or at any other of our upcoming conferences, for example, in Singapore or Greece. And yes, thank you once again. Thank you, Peter, Olivier, and everyone. And I wish you a good day and goodbye.
Thank you. Bye-bye.
Thanks. Bye.